Okay, in today's video, we will be solving functions when given a value. Um, so basically, we're going to be using the substitution method to solve these functions. So if we look at the first example, and we've done things similar to this before, so this might be more of a review, but the function that they give us is f of x equals 2x minus 3, or 2 times x minus 3. Another way of writing that same function is by using the variable y. We've been more used to seeing it in this format, um, but what we're going to focus on today is more of the actual function notation, which means we're really going to be using f of x equals 2x minus 3. Now, when we're evaluating this function, what that really means, that word evaluate, is solving. And they're asking us to solve it for f of 0. And so f of 0 then means our x value. Notice instead of writing x, let me correct this. Instead of writing x, I wrote a 0. And so that means in our function over here, we're going to substitute 0 in for x. So instead of 2 times x, we're now going to have 2 times 0. We're going to subtract 3 from that. 2 times 0 gives us 0 minus 3, which then gives us negative 3. So f of 0 equals negative 3. If we try our next example, we have f of negative 1. Again, we're going to plug in negative 1 for a function. Remember, our function is 2x minus 3, so we're going to have 2 times our x value. Well, in this situation, our x value is negative 1, and then we're going to subtract 3. 2 times negative 1 gives us negative 2, minus 3, which is negative 5. So f of negative 1 equals negative 5. And then finally, let me see if I can extend this a little bit. There we go. Um, our last example will be f of 0.5 equals 2x minus 3. So if it's 0.5, we take our x out, and we're going to say times 0.5 minus 3. 0.5, another way of looking at that is 1/2. I'm going to rewrite this so it's a little bit neater. So 2 times 1/2, or 0.5, actually gives us 1. And then 1 minus 3 is negative 2. So what we get is f of 0.5 equals negative 2. Okay. Another way to demonstrate this is by using a table. If you look in this table, we have 3 different functions, but we're going to plug 0 in for all 3 functions. So if we look at this first function, it's going to be f of 0, that's what we're plugging in for x, equals 3 times 0. Well, 3 times 0 is 0, so f of 0 equals 0. The next one, we will have f of 0 equals negative x, or negative 0 plus 1. Well, negative 0 is just the same as 0. 0 plus 1 is 1. So f of 0 would then equal 1. Our last function is, when we plug 0 in, we're going to have negative 2 times 0 minus 1. Well, negative 2 times 0 is 0 minus 1. F of 0 then equals 0 minus 1 is negative 1. If I pull this down, our next value that we're going to plug in is negative 3. And again, we're going to use this same function. So it's going to be f of negative 3 equals 3 times x. 3 times, and our x in this case is negative 3. 3 times negative 3 gives us negative 9. So f of negative 3 equals negative 9. The function in our middle column here, again, we're going to plug a negative 3 in. But notice this time it's a negative because there's a negative up here. Then we plug in our x value, which is negative 3. So we actually have two negatives. It's like a negative, negative 3 plus 1. We take our plus 1 from up here. Well, negative, negative, those kind of cancel each other out to make a positive. So we really have 3 plus 1. 3 plus 1 is, of course, 4. So f of negative 3 equals 4. Our last function, f of negative 3, and in our last function we're going to take negative 2 times our x value, which is negative 3, and then we're going to take all of that and subtract 1. So negative 2 times negative 3 is positive 6, because a negative times a negative is a positive. 6 minus 1 then gives us 5, so f of negative 3 equals 5. Okay, I'll let you go ahead and practice this last one for all three functions. You're going to have f of 0.5 when f of x equals 3x, negative 1, or excuse me, negative x plus 1, and negative 2 times x minus 1. Good luck.